In this video, we're excited to show you just how powerful AI can be for creating stunning visual content and enhancing educational experiences. We'll be using two of the best image-to-video AI tools out there, Luma Dream Machine and Kling AI. These tools will help us generate some truly amazing ballet videos, which we'll combine with an engaging lecture on brain plasticity. Our goal is to demonstrate how AI technology can transform education. In the first part of the video, we used Luma Dream Machine to create beautiful ballet sequences. You'll see how this AI captures the elegance and fluidity of ballet with incredible detail and realism. For the second part, we switched to Kling AI to produce another set of ballet videos, showcasing its unique strengths in creating captivating visuals. We hope you enjoy the video! Let us know in the comments which AI you think did a better job. Your feedback is really important as we explore the future of AI in education.
Brain plasticity in ballet is an incredibly fascinating and important topic creative minds alike because it vividly illustrates how our brains can adapt and reorganize through learning and practice. When someone learns ballet, their brain forms and strengthens neural connections that improve coordination, balance, and memory. This process, known as brain plasticity, shows that our brains are highly adaptable and capable of significant change. Understanding brain plasticity through ballet has broad implications. For scientists and engineers, it offers insights into developing adaptive technologies and rehabilitation tools that leverage movement to aid recovery. For example, AI systems could be designed to learn and improve over time, much like a dancer refines their technique. Inventors can apply these principles to the iterative process of refining and enhancing their creations, emphasizing the importance of practice and adaptation. For educators and trainers, recognizing how physical activities like ballet enhance brain function can inform new methods for teaching and skill development. Integrating movement into educational programs can boost learning and memory, making training more effective. Creative individuals can take inspiration from the adaptability seen in ballet, understanding that persistent practice and innovative approaches can lead to mastery and breakthroughs in any field. Ultimately, studying brain plasticity through ballet underscores the limitless potential of the human brain. It teaches us that with dedication and the right practices, we can continuously improve our skills, solve complex problems, and achieve innovative solutions. This knowledge empowers us to design better training programs, develop smarter technologies, and foster a growth mindset that can transform both personal and professional endeavors. Imagine the brain as a lump of clay, soft and pliable. This metaphor captures the essence of its incredible adaptability. This is the essence of neuroplasticity, the brain's remarkable ability to change and adapt throughout life. Neuroplasticity allows the brain to reorganize itself by forming new neural connections. Just as a sculptor molds clay into intricate shapes, our experiences mold our brains. Every thought, action, and emotion can leave an imprint on our neural pathways. Learning a new skill like playing a musical instrument is a prime example. When we engage in such activities, our brains are hard at work, creating and strengthening connections. As we practice, our brains rewire themselves. This rewiring is a testament to the brain's ability to adapt and grow. Neural connections strengthen, new pathways emerge. This dynamic process is ongoing, reflecting the brain's continuous evolution. This process is not limited to musical skills. It extends to any challenging activity that requires focus and practice. Any challenging activity, from learning a new language to mastering a sport, can reshape our neural landscape. These activities stimulate the brain, encouraging growth and adaptation. The brain is a dynamic organ, constantly evolving in response to our experiences. This adaptability is what makes us capable of learning and growing throughout our lives. This inherent plasticity is not merely a scientific curiosity. It has profound implications for our lives. It means that we are not bound by our past experiences or limitations. It underscores our capacity for learning, adaptation, and even recovery from injury. Whether we are adapting to a new environment or recovering from a setback, our brains are equipped to handle the challenge. The brain is not a static entity, but a vibrant, ever-changing landscape shaped by the dance of experience. Each moment, Each challenge and each triumph contributes to the ongoing masterpiece that is our brain. Ballet, often perceived as a purely physical art form, is in reality a harmonious blend of the mental and physical. It is a dance that transcends mere movement, embodying a symphony of mind and body working in perfect unison. Like learning a complex language, it demands rigorous training and discipline. Each step, each movement is akin to mastering a new word or phrase, requiring dedication and perseverance. Every graceful arabesque, every precise pirouette, is the culmination of countless hours of practice, repetition, and refinement. The dancer's journey is one of continuous improvement, where each performance builds upon the last. The dancer's body becomes an instrument of expression, but it is the mind that orchestrates every movement. The emotions conveyed through each gesture are deeply rooted in the dancer's mental state, making each performance a unique and personal experience. Visualizing complex sequences, memorizing choreography, and maintaining perfect timing require intense focus and cognitive agility. The mental rehearsal is as crucial as the physical practice, allowing the dancer to internalize the movements and perform with confidence. The dancer must be acutely aware of their body in space, coordinating their movements with musicality and grace. This heightened body awareness is a skill honed over years of training, enabling the dancer to move seamlessly and effortlessly. This intricate interplay of mind and body is what sets ballet apart as a uniquely challenging and rewarding pursuit. It is a dance that demands not only physical prowess, but also mental resilience and creativity. It is a testament to the brain's remarkable plasticity and our capacity for achieving seemingly impossible feats of physical and mental dexterity. Through ballet, dancers push the boundaries of what is possible, showcasing the incredible potential of the human mind and body working in harmony. Exercise, often touted for its physical benefits, is equally crucial for our cognitive well-being. Just as physical exertion strengthens our muscles, it also acts as a potent growth hormone for the brain. Ballet, with its demanding physicality, provides a particularly potent brain boost. Studies have shown that regular exercise, especially aerobic activities like dance, can increase the volume of the hippocampus, a brain region crucial for learning and memory. Exercise also stimulates the production of brain-derived neurotrophic factor, BDNF, a protein that promotes the growth and survival of neurons. In essence, exercise nourishes and rejuvenates the brain, enhancing its ability to learn, adapt, and thrive. Ballet, with its unique blend of physical exertion and cognitive demands, offers a powerful pathway to a healthier and more vibrant brain. Orchestrating movement, the brain's symphony in ballet. The human brain is a marvel of intricate coordination, and nowhere is this more evident than in the complex movements of a ballet dancer. Every leap, turn, and graceful extension is a testament to the brain's extraordinary ability to manage and synchronize countless neural processes. Imagine a symphony orchestra, each instrument playing its part in perfect harmony to create a breathtaking musical tapestry. The conductor, with a mere flick of the wrist, guides the musicians to produce a seamless blend of sound. Similarly, different regions of the brain work in concert to produce the fluidity and grace of a ballet performance. Each brain region, like an instrument in the orchestra, has a specific role, contributing to the overall masterpiece. The motor cortex, responsible for planning and executing movements, fires signals to the muscles, dictating their every contraction and extension. This region of the brain is like the conductor, ensuring that each muscle group performs its part at precisely the right moment. The cerebellum, the brain's maestro of balance and coordination, ensures smooth, precise movements. It fine-tunes motor activity, allowing the dancer to maintain perfect balance and execute complex sequences with ease. The parietal lobe processes spatial information, allowing the dancer to navigate the stage with accuracy. It helps the dancer understand their position in space, ensuring they can move gracefully without colliding with other dancers or stage props. This intricate neural symphony underscores the remarkable complexity of the brain and its ability to orchestrate even the most demanding physical tasks with astonishing precision and elegance. The brain's ability to integrate sensory information, plan movements, and execute them flawlessly is nothing short of miraculous. Each performance is a testament to the brain's incredible capacity for coordination and control, making ballet not just an art form, but a celebration of human neural ingenuity. Sculpting the brain: how ballet shapes our neural architecture. Just as a sculptor meticulously chisels away at stone to reveal a masterpiece, years of ballet training sculpt the brain, enhancing certain regions and strengthening neural connections. Magnetic resonance imaging, or MRI scans, provide compelling evidence of this neural transformation. Studies have shown that professional ballet dancers have increased gray matter volume in areas of the brain associated with motor control, balance, and spatial awareness. This suggests that years of rigorous training lead to structural changes in the brain, optimizing it for the specific demands of ballet. These findings highlight the profound impact of experience on brain structure. The brain is not a static organ, but a dynamic, adaptable entity that molds itself in response to the challenges we embrace. The future of brain plasticity is incredibly promising, with recent research uncovering groundbreaking insights and potential applications across various fields. Advances in understanding brain plasticity are revolutionizing the way we approach rehabilitation for stroke, traumatic brain injury, and neurodegenerative diseases. For example, therapies such as constraint-induced movement therapy, CIMT, leverage brain plasticity to improve motor function in stroke patients by encouraging the use of the affected limb. Additionally, virtual reality, VR, and brain-computer interfaces, BCIs, are being developed to enhance neurorehabilitation by providing immersive and adaptive training environments that promote neural reorganization. Educational strategies are increasingly incorporating principles of brain plasticity to enhance learning outcomes. Techniques such as spaced repetition, active learning, and gamification are designed to strengthen neural connections and improve memory retention. Recent research has shown that incorporating physical activity into learning, such as dancing or aerobic exercise, can boost cognitive function and facilitate better learning through enhanced brain plasticity. Brain plasticity plays a crucial role in mental health, offering new avenues for treatment of conditions like depression, anxiety, and PTSD. Techniques such as cognitive behavioral therapy, CBT, and mindfulness meditation have been shown to induce positive changes in brain structure and function, promoting resilience and reducing symptoms. Moreover, emerging treatments like transcranial magnetic stimulation, TMS, and deep brain stimulation, DBS, directly target neural circuits to enhance brain plasticity and alleviate mental health disorders. Research into brain plasticity is providing hope for mitigating age-related cognitive decline. Interventions such as cognitive training, physical exercise, and social engagement are being used to maintain and even improve cognitive function in older adults. Studies have demonstrated that these activities can stimulate neurogenesis, the growth of new neurons, and synaptic plasticity, helping to preserve cognitive abilities and reduce the risk of dementia. The principles of brain plasticity are inspiring advancements in artificial intelligence, AI, and machine learning. AI systems are being designed to mimic the brain's ability to learn and adapt over time, leading to more robust and flexible technologies. For instance, neural networks, a key component of AI, are modeled after the brain's neural pathways, allowing machines to recognize patterns, make decisions, and improve their performance through continuous learning. The future of brain plasticity holds immense potential for improving human health, learning, and technological advancement. By continuing to explore and harness the brain's remarkable capacity for change, we can develop innovative therapies, educational strategies, and technologies that enhance our abilities and quality of life.